Thank you everyone for coming. For those of you who don't know me, my name is Daniel Cilliers. I studied IT3 in ISA. Currently work for Mercury as a PHP developer, and prior to that, I was with Payfast for 6 years as a full stack developer. So, if your payments don't work, it wasn't me. But at these two companies, my previous and present, I have extensively worked on legacy code. My previous boss hired me to pull apart legacy systems, and now I'm doing it for my current one. So, I just wanted to come here today and share what I learned with all of you. Now, some disclaimers about this talk. I am a terrible public speaker. So one of the reasons I came here today, see how I could improve it, and what better way to do that than share my experience with you about my legacy systems. I do not have a master solution to get rid of a legacy system. So you're not going to leave this talk going, cool, this is exactly what we're going to do, done and dusted. My aim is to give you tools to help you get rid of a legacy system and identify the problems. This is not a microservice talk. If you're looking for microservices and designs, we'll be touching on them, but it's not solely just about microservices. This is not a coding talk, it's more of an architectural talk, intermediate level, no code examples. I wish I could show you a code example that will just fix your legacy, but I'm still looking for it myself. Now, I'm not the best developer. Please keep your expectations realistic and low. My Stack Overflow is 574, and my GitHub contribution diagram looks like a sprite from Doom 95. But, okay, jokes aside, I just want to share what I've learned. I by no means know everything, but I'm hoping some of you can leave here with some value from my own real-world experience with legacy. So, you'll never get rid of legacy code. That's a hell of a statement of me to say. And why do I say this? Why can't you get rid of it? Why should you be concerned about this? What can you do about this prediction of mine? In this talk, we're going to cover three things. What is a legacy system? What stops you from getting rid of a legacy system? And how can you get rid of a legacy system? Just the FYI, sorry about the Chrome window. We had a situation, but it's working now. So, I want to start with a question to set the scene. What do space shuttles and the Romans have in common? Now, if you know the answer, don't spoil it for someone. The Romans built the first long-distance roads in Europe, including England. No, I didn't even know England was part of the Roman Empire up until my research for this talk. They used 2 horses to draw their wagons, and then this became the standard within the Roman Empire. And the spacing of these 2 horses behinds became the spacing of the wagon wheels, which was 4 feet, 8.5 inches. And these wagons are used on all of these roads, eventually started to carve ruts or tracks into them, as you can see on this photo. And this meant that any wagon that came afterwards had to have the same spacing, or else the ruts would cause the wheels to hop in and out and break. And for future roads the Romans built, they even deliberately carved these in for very popular roads, as it assisted the wagon with steering, provided it had the correct spacing. And as a result of this, everyone had to conform to this spacing. Now, a couple hundred years after the Roman Empire, the British built the first tramways or pre-railways. And they built these using the same jigs and tools they had previously used to build the wagons. And as a result, the tramway gauge, which is the distance between the 2 tracks, was the same as the old wagon tracks, which was 4 feet, 8.5 inches. After the tramways came the modern railroads. Ignore that. So the British built these railroads on top of their existing tramways, which meant the railroad tracks had the same spacing or railway gauge as the tramways. Thereafter, the British went over to the US, and they built the first railways there using the same standard as they had in the UK. Fast forward about 200 years, and a couple of NASA engineers are designing the solid rocket booster. They're the ones that go on the side, the two skinny ones, and there's a problem with this. They don't build this. There's a company called Teocol, I hope I'm pronouncing that right, in Utah, which built these. And Utah is a long way from the Kennedy Space Center in Florida. So they needed to transport them by train. And this railway has a tunnel. And how wide is this tunnel? Well, it's a little bit wider than 2 Roman horses, or 4 feet, 8.5 inches, because of the railway gauge. The NASA engineers had the design of space travel limited by 2,000-year-old mode of transportation. The decisions you make today will impact your code base's application features, your DevOps, your revenue, your business flow, your sanity for years to come. The next time you look at a code base and go, oh, why is it this? Who wrote this? Why are we doing this? Then you're going to know it's because somewhere in the code base's history, a decision was made and left in place for so long that it is now too late to go back on it. The code is too intertwined, and the system is too dependent on it. So, what can you do about this? Well, we first need to know what a legacy system is. If some of you recognize that code there, then you definitely know what a legacy system is. Now, I just wanted to find what a legacy system is because I don't want you leaving this talk, going back to work saying, shit, we need to pull apart our system. And you got to make sure it's really legacy before you jump into that. Okay, a legacy system is not a monolith. Just because you've written a monolith service does not make a legacy. I know microservices are the rage right now, slowly fading out, but just because it's monolith does not make it legacy. There's even a talk about it today. It happened in the previous session, monolith to monolith. Recently written code is not legacy code. You can't argue that, oh, well, this code is a year old, it's legacy. No. There are a bunch of factors that create a legacy system over time. Technical debt, business process flow changes, aging integrations and technologies. So we're going to cover these later on. It is a code base which has technology that is no longer supported. 16% of the internet is still using PHP 5. That's scary. Probably WordPress sites. And according to W3 Tech, approximately 71% of the internet uses unsupported versions of jQuery, including Stack Overflow, which uses version 1.12, but still version 1. A lot of healthcare and financial institutions are known for using outdated versions of Delphi. I mean, you can go on about that one. Its core technology has not been updated since it was written. This is different to the technology no longer being supported. PHP 5 was still supported when PHP 7 was launched, but systems using PHP 5 were already showing their age in 2015 with the launch of PHP 7. When you have to start using significant hacks to implement a new feature or a modern technology, you have a legacy system. You'll know it when you see it. You're asking the system to do something that it was not originally meant to do. And we're not talking about a few unwanted if statements here or there, but we're talking about code that goes against the design of your application. I mean, it can be small things like storing a serialized string in a column that was meant for JSON, to larger things like hacking in a new ORM. Please do not do this. It is a nightmare. Hard coding user IDs to skip process flows and order IDs. And I mean, I'm sure everyone here who is working on a legacy system or will be is going to find a lot of examples of what I'm talking about here. So, what stops you from getting rid of legacy code? Can't we just write a new monolith, kill the old one, plug and play? I'd love to. But the risks and costs involved are too great. This is what I feel is the biggest reason. Businesses are risk averse. They want to make money. The financial risk of implementing a new system to a company is huge. It's massive. And it's easy as a developer to go, well, I'll just do it. To those of you who are business owners here, you'll know how that coin changes. And this is whether your business is big or small. It's not just the big boys affected by this. Small businesses need to make revenue. Although large companies are normally the ones with legacy systems. You'll be told if it's not broke, don't fix it. And you're going to need to convince your stakeholders, listen, this thing is held together with duct tape and glue. It's going to break. We need to act now. Stakeholders will be reluctant to invest time and money into a system that will do the same thing. Sure it will, but with improvements. Because the system is working as is, so why invest that time and money? Time is expensive. It's your most valuable asset when it comes to this problem, but also in life. So to the business, time is better spent implementing new features to grow the system, rather than putting the system's growth on hold for a year, 2 years, while you're doing a rewrite. Technical debt also stops you. What is technical debt? Technical debt is the cost of maintaining and updating a code base to keep up with changing technologies and requirements. So, legacy code bases accumulate a hell of a lot of technical debt over time, and this makes it really difficult to refactor. Probably the most common example of technical debt I've seen in various systems is auto-incremented IDs versus UUIDs. If you want to upgrade that, swap it out, very difficult to do. You have to maintain your historic records for reporting, for your system to work, and then you have to make sure your DB queries can handle the new 16 bytes UUID as opposed to auto-increments, which is 8. Once technical debt like this runs rampant in your system, you're going to have a very hard time getting rid of it. Code complexity. Legacy code is complex. It's been built up over many years by different developers, each one thinking they know what's best. Oh, did you see this ORM? Oh, look at this new methodology, let's try this. And then, you know what I'm talking about. As a result, you have large pieces of interdependent code that is difficult to modify. And the code has become so intertwined, you end up with core functions, which are functions that are like hundreds of lines long. They should have been a class. And if you want to update something in these functions, like logic flow, the parameter or return type, I've broken a system with the return type. If you want to change those things for one task, you could introduce so many bugs elsewhere in the system. I don't know how many times you've had to add in a new parameter with a default value to a function, just for use in one place, but not in the other 20. Legacy code often lacks documentation. This is a big one. It takes time to learn and understand the complexity of a system, and documentation helps with this. If you don't understand the code base, you're not going to understand what impact the changes you have are going to make. Lack of code coverage. Legacy systems are notorious for not having enough code coverage or test coverage. And as a result, people are too scared to change the code. I've seen it. It's risky stuff. And I'm also very guilty of not writing enough tests myself. We take the easy way out as developers, get this task across the line, sprint's almost ending, skip the test, we'll make a backlog ticket for it. Never get to it. And now as a result of not having enough test coverage, when you do make a change, there's an undesired effect you may not be aware of. You miss it, QA misses it, stakeholders miss it, and then it releases, and then boom, you have a new bug in your system. Third parties have requirements out of your control. Now, a lot of legacy systems have implemented special rules and process flows for third-party integrations. And what they find later on is, cool, we're doing a system rewrite, and they come across this piece of code, and then you realize, ooh, if we move this integration is not working anymore. That's a problem for revenue. Now, if you're big enough, you can throw your weight around. Shopify did this a couple of years ago with their rewrites. You either conformed or you didn't. But for those of you that aren't big enough, and you're just going to end up carrying that integration code with you if you do a rewrite. Now, some examples of these restraints that they place on you. Special integration requirements, such as, can you skip this step for us? You'll ask that so much. Or our system won't be able to call you at that stage. Can we do a recon later? Now you're like, now I've got to build a whole recon functionality for you. And then, anyway, we actually had a very interesting partner put in a request yesterday that made me shake my head. SOAP and XML. This is not dead technology, going extremely strong in the finance world. So if you've integrated with a finance company using this, you want to move away from it, only do REST and your JSON and all the new stuff, you're going to have to carry this with you for the new system so the integration works. Opposing architectures. So a lot of people, well, I say a lot, but a good portion of people are moving to GraphQL. It's the new kid on the block in recent years. But if you have a system that uses GraphQL and your integration partner says, look, we can't do an RPC call, GraphQL call, you're going to have RESTful endpoints in your system to accommodate for them. So you can partially improve on integration code during a rewrite, but your overall classes, the flow of the logic, is going to remain mostly the same. And if you do a rewrite, you're just going to end up copying and pasting that legacy code as is. I've done it. You look at code, you copy, you paste it, you change the syntax, and you have the same code in your new service. Now, this means if you rewrite the rest of your system, you're going to end up copying and pasting a lot of code, as I said, because you just can't change it. And you're just going to be stuck with their legacy code as well. Business continuity. Legacy code bases support critical business functions, and replacing this is very costly and disruptive. Convincing stakeholders to break this continuity it's a hard task, even if it's just temporarily. Even for a 12 o'clock midnight launch, it's, yeah, big ask for some systems. New features. Legacy code bases are continuously growing, as should any code base. That's why we wrote code. We want to improve, iterate. But it's hard to replace a legacy code base while it is still growing. So what ends up happening is you have your legacy, you've got your new service you're writing, and marketing says, hey, can you do this promo code for us? People hit this endpoint, whatever. You add that endpoint to this system and you add it to this new one. You're duplicating work, you're making your legacy grow. It makes it very hard to get rid of a system while still adding to a system. And on these requirements, stakeholders often have very strange new feature requests for legacy systems or any system that you didn't intend in the process. Now, you'll see this more in legacy systems because they've had the time to accumulate these requests. But these are often requests that they're asking the system to do things it wasn't meant to do. And that creates more technical debt, more complexity, and interdependent code. It kind of reminds me of the situation. I don't know if you guys can read that, but let me just read it for those that can't. We've written a system that will draw the perfect circle. Can you also make it draw 7 red lines, all strictly perpendicular, some with green ink and some with invisible ink, transparent ink? Right, the Pareto principle. This is an interesting one, stopping you from getting rid of legacy systems. Does anyone know what that is? And I hope I pronounced it right. It's commonly referred to as the 80-20 rule. The rule states that if 80% of your revenue comes from 20% of your customers, that you should focus more time and effort on that 20%. So, what does this mean for your code base? You'll spend more time doing ad hoc and bespoke projects for high-profile clients, often requested at the last minute, on tight deadlines, which then leads to developers taking shortcuts, which then leads to code complexity and a hell of a lot of technical debt just to get the job done. The requests often go against what the system was designed to do, and by agreeing to the requests, you introduce more technical debt, and you can even add additional strain onto the system. A recent example I can think of is we had a customer ask us, can you query all the users for a country just to display a different menu? Sounds simple, but that's a big load on the DB. It's a lot of queries for that. Thought it was coming from down below for a moment. Okay, so to recap, the risks and costs involved are too great. Technical debt, code complexity, lack of code coverage, third parties have requirements out of your control, business continuity, new features, and the Pareto principle or the 80-20 rule. These are the things stopping you from getting a relay system, at least the major things I wanted to highlight. I have a little acronym that makes this list a bit easier to remember. Trademark pending. So, how can you get rid of a legacy system? I've told you, you've got all these blockers. So what are we going to do about it? Well, refactor your code. This is step one. Don't look at microservices. Don't look at new architecture. Don't look at anything new. Refactor that code first. Don't try new fancy things, containerization, none of that. This is your best tool for getting rid of a legacy system. Refactoring your code base will greatly improve the readability and maintainability of your code without changing its behavior. Very important, that keeps stakeholders happy. Refactoring will remove code duplication and redundancy. Please retire unused code. Delete it. You don't want dead code in your system. Why is this unused file here? Get rid of it. It will simplify complex legacy code. You can introduce coding standards and best practices during a refactor. It's never too late to do this. Do it sooner rather than later. If you refactor your legacy system, you're going to extend its life. And we're talking years here. You could even push it to a decade, depending on the system. So for some situations, and for some of you, you're going to sit down, you're going to go, cool, we've got this legacy code base, let's refactor it. And after the refactor, you're going to take a step back and go, hang on, we don't need to replace this anymore. This is fine as is. Now, after you've refactored, you want to move on. Use an incremental approach. There's that old saying, how do you eat an elephant? One bite at a time. No reference to PHP. You can't do it all at once. You have to take an incremental approach for pulling apart your legacy code base. But how do you know where to start? Right? You start at the trunk, the tail, you have to look at your code and ask yourself, what adds the most value? Not financial value, but value to the code base. What's going to reduce the impact on the code base a lot? Is there an area of the code doing a significant amount of queries? Can we pull that out? Let it have its own service, its own DB. Reduce the database load. What these things are will differ per system, but this is a very important question to ask yourself. Identify parts of the system that can function on their own and split it out. If it can function on its own, don't keep it there. Examples of this: messaging services, forward services, KYCs, document uploaders, APIs. Split them out and reduce the size of your legacy system. Now, these are just two of the things to look at before starting your microservices. And I'm not saying you should go the microservice route, but knowing these two things help. Write modular code. And you must be able to swap out parts of your system, and you can't do that if your code is not modular. Now, this may seem very obvious to us as developers, even to those of you who are not developers, right? But modularity gets lost in the legacy system over time. You think you're maintaining it, and then you blink and it's gone. So, how can you make your code more modular? This talk is not about design principles, but I'll just cover some methodologies here that could help you with your coding approach. Solid, the most famous one we all know, most well-known OOP coding methodology. It works and it works well. Now, inheritance isn't perfect, but it's close. But use it carefully. With great inheritance comes responsibility. So, just a quick recap what Solid is. Single responsibility. Every class should have one responsibility. The open-close principle. Objects must be open to extension but closed to modification. The Liskov substitution principle. This one gets everyone. So, objects of a superclass should be replaceable with objects of the subclass. You want your objects of the subclass behaving the same as the objects of the superclass. To sum all of that up, code against an interface. Which takes us to interface segregation. Clients should not be forced to depend on interfaces they do not use. I've seen this. Do not do it. Dependency inversion. Depend upon abstractions, interfaces, not concretions. Abstractions should depend on the details. The details should not depend on the abstraction. Now, this next one is quite interesting. I wanted to throw it in here. It's very applicable to microservices, but you can still use it for your code as well. It's a fairly new idea. It's called ideals. So, the I is for interface segregation. So your different clients, your mobile app, your web app, your CLI, all of these should be able to interact with the service through a contract that's best suited for them. Deployability is on you. What this means is the developer is responsible for the software and making sure that its versions are readily available to its happy users. You worry about the other users later. Events driven. Where possible, the microservice should use asynchronous calls or events instead of synchronous calls. Availability over consistency. I found this one quite interesting. Users value the availability of a system over the data consistency of a system. And now, according to everything I looked at regarding this, what they actually found was users will eventually accept that data consistency will come later. So I found this one very interesting. Loose coupling, your services should be loosely coupled. Your senders and receivers must not be aware of each other. Do not make your services interdependent. Single responsibility, very similar to Solid. A microservice should not be too big or too small. It must have just the right amount of functionality to do what is asked of it. We have written very small microservices. Could it have been a package? Maybe. Did it need to be a microservice? Probably not. We've written very large microservices, which just becomes another monolith service. So keep that in mind. Another methodology for your modular code is composition, one of my favorites. I actually tried to submit a talk, inheritance versus composition, regarding this. So the principle of composition is that a large problem is decomposed into smaller problems. It's impossible to solve a complex problem without breaking it down, and composition is fundamental in every code base. You probably already have it implemented without knowing it. Now, some people see this as an alternative to inheritance, which is a heated debate, and not quite true. Each have their pros and cons. I'm not going to go into it in this talk, but very interesting read, composition versus inheritance. Another approach, if you don't want to go microservices, is sacrificial architecture. There's a guy called Martin Fowler. He wrote a post. Well, I say a post, it was a full article in great detail about this. It was very interesting. And this can be seen as an alternative to incremental approach, but you'll also really end up using it on your microservices. So, sacrificial architecture is writing code with an expiration date. To think that we write code and it's around forever, it's a mindset we need to move away from. It's true that code that has been around for so long and is working is very impressive, but you can build great code on top of discarded code. Now, two companies that have proven this model is eBay. 1995, a couple of guys and some Perl scripts in a garage, put some code together, and eBay was created. 2 years later, they scrapped it all, replaced it with C++ in 1997, and then thereafter in 2002, they killed all of it again and replaced it with Java. With each iteration, eBay killed the code base and replaced it. They sacrificed it. What eBay does now is they now still do this, but now they have all their services, so they will kill a service if it no longer meets their needs, and write a new one. Google's a good example. When Google designs a system, they design it to meet 10 times its current needs, and when it reaches those needs, once again, they scrap it, they kill it, and they start fresh as well. They don't try make a new iteration of that system that wasn't working. And they do this every couple of years for some systems. It's a fairly common practice for them. Do not get emotionally attached to your code. Replace it when it no longer meets the requirements of the system. The architecture you used when you started your legacy system may not be the best for the present anymore. And you just got to replace it at some stage. Establish test coverage. If your code base has comprehensive test coverage, it's easy to replace parts of it. And you'll know what your code is expecting with test coverage when you make a change, because your tests are going to fail. Unit tests and integration tests are the main ones, but you can include any tests that's unique to your business system or needs. And of course, if you have the tests, you can further modernize your legacy system by throwing in some CI/CD pipelines. Iterate and optimize the code. I like to think of this as updates sooner rather than later. Hindsight's 2020. We can all look back and go, oh, we should have done this. Oh, how did we miss that? What were we thinking? I do that when I go right-click annotate. But sometimes they're just things you can't see, but other times there are things you can see. So, update sooner rather than later. If you see something's going to be a problem, which we have seen before, act now. For example, also incremented IDs and a fixed column size. If you know those IDs are going to run out, which happened to another company recently, I forgot their name, but it was quite a big problem for them. They couldn't make any new orders. Imagine if the railway builders said, hey, let's make these train tracks wider, let's have a new gauge for bigger cargo. I mean, the Industrial Revolution was happening, like it made sense. Why didn't they do it? Who knows what the first space shuttle launch would have been like with larger SRBs. There's no better time to start introducing modern iterations to your code than now. Iterate and optimize. This is going to prevent future problems, and it's going to improve your code and get rid of a hell of a lot of redundancy. And containerize your legacy code. Now, this one's optional because it's not applicable to everyone, but if possible, try and containerize your legacy system. It'll help isolate your legacy code from the rest of your system, and this is very dependent on the environment you have, so just please keep that in mind. But if it is isolated, then you're going to be able to manage, maintain, and scale it better. Legacy systems are often not great at scaling. They were written before the scalability era. Do not underestimate the power of documentation. A very important tool for getting rid of a legacy system. Something as simple as a README makes a huge difference. So do the API docs. Like, it goes such a long way. It'll speed up the refactoring and building of microservices significantly. You've got all the endpoints documented there, you know exactly what you need to do. But a very important thing is it reduces the complexity of the learning curve. New developer comes into a company, it's got this massive legacy system. It takes a long time to learn. That's time lost to the company, the developer's getting frustrated, he's not understanding the code's not getting rewritten. Documentation will go a very long way. You want to know the system you're working on, and you want to know it well before you start considering ripping apart your legacy system, and documentation does wonders. Question, process flows, and logic. This is one of my favorite ones. At one stage, I was known for asking why and not accepting things. So when you're refactoring code and you're pulling it apart, don't be afraid to ask questions. We had a lot of meetings with people, we're doing a scrum, people just sitting there going, oh. And I've done it before as well, but I'm trying not to. And don't be afraid to ask the other devs or the stakeholders when something comes up, why was it done this way? The decisions that were previously made back then may not be the best for now. And we touched on this with the sacrificial architecture. Don't accept, oh, this is how we've always done it. Instead, ask yourself, how can we optimize and modernize this code? Otherwise, if you don't, you're going to be blindly copying and pasting code across for a rewrite. Prime example is events. Just because your old system did a polling call to fetch data doesn't mean your new one has to. Don't blindly copy it. Go, is this the best for us right now? Oh, no, it's not. Let's use events. I think 2 questions that are very helpful to ask yourself during a rewrite is this the best solution for the present day? And do we still need this flow? So, just to recap, an incremental approach. Refactor the legacy code. Modular code. Your code has to be modular. Sacrificial architecture, if you choose to go that route and not microservices. Have test coverage. Iterate and optimize your code. Please do this after the refactor. Containerize your legacy if you can. This is quite a tough one. My DevOps is absolutely horrible. I know how to start Docker, and that's where it ends. Document your code base. Massive help to new people joining the company, but even existing people who may not have worked on a part of a system now get to see what the rest of the system does. Question the process flow and logic as well. Ask yourself, is this the best for us today? I've got another acronym there for you. This one is a bit easier to read. Duct. Also trademark pending, please don't steal it. I've got 2 bonus ones before I move on. I don't quite want to add these on their own slide, but because we kind of touched on it in general, but a very quick win for breaking apart a legacy system, split out the front end. Well, I say quick, but if you can get that right, that's a very, very nice step to do. And people are calling this BFF, not best friends forever, but back end for front end. You'll pull it out, and it will have its own little back end, which is basically just endpoints, hosting its front end, and then the 2 backends will speak to each other. And the second bonus thing I wanted to throw in here, also wasn't sure where to add on the slides, is if you want to take some steps to get rid of your legacy system, just allocate a little bit of time in your sprint for tech debt. We try to do this, some sprints we succeed. I know it's hard because you've allocated these points this time and then things come in and then those fall by the wayside. But where possible, try to do that as best as you can. So, in conclusion, it takes years to phase out a legacy system, even with the architectural approach, sacrificial architectural approach. And you need time. Time is going to be your most valuable asset for this. The issues I've highlighted today need time. Be patient with your legacy system. It's working hard. It's going through a lot. Okay. If you just take your time, piece by piece, go through the points I've mentioned here, sort out your technical debt, remove what's putting strain on the system, and so forth, then you'll slowly be getting rid of your legacy system. Thank you.